Hello, my dear audience, and welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. If this is your first time tuning in, welcome to the podcast, and I'm sure that you want to hear about next generation sequencing, and that is why you're here. So let's go ahead and jump right into it. In this episode, I am joined by Dr. Jose Alexander and Daniel Navas from Advent Health Orlando, the Microbiology Lab. And they go over the whole process of how they implemented next generation sequencing in their lab. So they talk about the validation, the organisms, why bring it to the lab. And this episode was actually released last year. But now that we have a little bit of a broader audience, I thought it will be a good time to re-release it. And as you know, the Let's Talk Micro podcast is supported by the American Society for Microbiology. To learn more about microbes, visit asm.org. So let's go ahead and jump into the episode. So maybe if you are a medical laboratory scientist student, or you're a microbiology student, or you just work in the lab already, and you definitely hear terms like next generation sequencing, you hear terms like whole genome sequencing. Maybe you send an organism that you couldn't identify in your lab, and then when it comes back, you see, or you read it on an article that it was ultimately identified by whole genome sequencing, right? So today we're here to talk more about that. I always enjoy how this platform, it allows me to talk to guests from different parts, but it's always special when I get to do it right at home. So today's guests are from Advent Health. One of them, he was already a guest before episode 73, an episode about amoeba, which is Dr. Jose Alexander. And with me today, I have also Daniel Navas. Dr. Alexander and Daniel, welcome to Let's Talk Micro.
Hi, thank you. Thank you for having me here.
Hi, Luis. Thank you. Thank you for having me.
Definitely a pleasure. So I already, said your names and where you work at. So can you, for the audience, talk a little bit about what you do at Advent Health, please?
So my name is Daniel Navas. I am the technical coordinator at Microbiology Department at Advent Health Orlando. My role as a technical coordinator is to basically validate new testing methodologies and systems that come into the market or the field, and also train the staff in all these new methodologies. All these projects can include things like new antimicrobial susceptibility testing. It can include things like establishing a bacteriophage bank, and our most recent project, which is implementing a DNA sequencing protocol in our lab.
Well, my name is Dr. Jose Alexander. I'm the medical director for the microbiology department. I work closely with both of you, with Daniel and with you too, Luis. So part of my role is the technical oversight of the laboratory and being able to guide some of the process for validation, but also for the technical process that we follow in the laboratory as part of the standard operation procedures. And I also have a clinical role that is as a microbiology consultant with physician and other departments as infection prevention and pharmacy, helping coordinating with them the operation of the laboratory, the partnership that we have, cooperation, but also assisting with interpretation and even beyond, in some cases, with infection disease physician to try to find specific treatment for patients that have multiple drug resistant. All of that information and all of that conversation basically go from the perspective of the capability that we have in our laboratory to be able to perform testing for new antimicrobials, to be able to explore synergistic activity, to be able to explore resistant mechanism, and integrated this type of knowledge into the discussion for an advanced and maybe more precise treatment for some of those patients.
Excellent. So definitely, welcome again. So now that, so we do hear terms like next generation sequencing and whole genome sequencing. And I guess, Daniel, can you talk a little bit more about what's the difference between, NGS, next generation sequencing, and WGS, whole genome sequencing?
Sure. Okay. So NGS, or next generation sequencing, is defined as is a technology used to determine the sequence of DNA by sequencing thousands of strands simultaneously. It was initially called massively parallel sequencing because It enabled sequencing many of DNA strands at the same time. And this is compared to the more traditional methods like Sanger sequencing, which is one strand at a time. And then whole genome sequencing is a type of NGS, which allows for it provides for analysis of organisms like complete genome compared to more targeted sequencing approaches like 16S and things like that.
Thank you. And so that brings the question. So how does it work?
So NGS is divided into different steps. As far as just DNA sequencing, you first need DNA extraction and purification. So there's different methods to do this. There's different instruments and kits and all these different methods like spin column based, or there's magnetic bead based, like silica based. In our specific protocol, we have a in-house validated extraction protocol, which is more of a cell disruption. We use glass bead tubes and we put in a bead beater. We do sonication and we really disrupt the cell wall and able to get that DNA. And then we do a centrifugation. And that's kind of our in-house validated protocol, more for identification purposes. But there are other extraction protocols that give you that what you call ultra pure DNA, which different kits and stuff. We use those for when we have more significant applications like genomic epidemiology or looking for resistant markers or something like that. So that's the first step, would be just extracting your DNA. And then once you have your DNA extracted, you have the library preparation. So library preparation includes adding your barcodes, unique barcodes that are used for multiplexing. You also have the addition, in our case for our protocol, the addition of a rapid adapter. The rapid adapter has the motor protein in it, which allows for the attachment of the DNA strands to go into the what they call the nanopores. And then once you have the library prepped, you have to load it into a sequencing instrument. So there are there's different types of sequencing instrument. For us, we're using the Oxford Nanopore MinION Mark 1C. It's a small portable device that performs base calling live. And then once you have, once you put it into your sequencing instrument, you go into data analysis. And there's different ways to analyze data. There's the cloud-based or local data analysis that could be performed. For us in our lab, we use Nanopore's cloud-based analysis called the WIMP, or the What's in My Pot. And then we also have local analysis that we could do using the Kraken workflow, which is has a larger database and can be used for different applications like resistant markers and stuff. But that's like a quick summary of it.
Excellent.
So one of the interesting thing is, just to complement what actually Daniel mentioned, we're also trying to look for a perspective that was adaptable to a microbiology laboratory. And I think actually Daniel can share some of the picture of the bench where we perform the NGS, and you can put some of those pictures in the podcast and the device. But the way the microbiology laboratory normally operate, so we are required to have a rapid turnaround time, to be highly efficient on the way that we operate. So when we implementing MALDI-TOF, or when we implement any PCR method, we need to adapt these instruments and these tests to the operation of a laboratory. So if you see around most of the NGS platform and solutions are highly focused in oncology, in a highly advanced laboratory, or at least in a way that is distributed with the main focus of the department is molecular diagnostics. But we know that many microbiology laboratories are not built in that way. So to be able to read NGS, how just Daniel mentioned, we needed to be able to develop some in-house programs. So we were able to do it without abstraction. Right? So we need to have a 30-minute rapid physical disruption that gives us enough DNA for an accurate and a reliable identification, but it's also rapid and simple, that we don't require additional reagents, more time or instrumentation for the extraction. So that process for rapid identification of mycobacteria, bacteria, and now we are exploring the option for yeast and molds, is part of the core component of the NGS that we develop in National. The process from that perspective, library preparation, follow the manufacturer recommendation, the equipment, the two different analytic platform, the WIM, that is our basic and to-go identification platform, but we also have a cracker that based on the validation that was performed, we know when we need to use it. The best example, Mycobacterium abscessus. Mycobacterium abscessus group is require a lot more of DNA and more quality DNA to be able to differentiate between Mesniensis and abscessus species. So being able to use a different approach for extraction, but even being able to use a cracker can give us the option to actually differentiate into species from that group. So part of the validation also consider the complexity of some organism and to what point we need to report a group, or to what point we feel comfortable and confident enough to report a species. And the validation process actually demonstrates that with the database that we have and with the process that we develop. If the organism is in the database, we have over 99% agreement in the validation. That is excellent from the perspective of validating NGS in a rapid microbiology lab. So if you see the NGS approach with a 24-hour turnaround time, everything can be set up in probably 2 hours. And the analysis, the run is overnight, but the next morning we are already analyzing the data. So that's how we used to use Vitek before the MALDI-TOF. So you set up an ID card and you wait until the next day to be able to have, right? Even when you know that some of the ID can come in less than 24 hours, you normally wait until the next day. So we have the same approach now for mycobacteria. So for first time, we have the capability to identify more than 99% of mycobacteria in just 24 hours.
Awesome. That's amazing. And I know, so you and for those of you that maybe, might be just starting to listen to the episode now for some reason or anything, just, we're talking about how NGS was brought to a microbiology lab. And definitely, Dr. Alexander touched on some of the challenges that it comes. And I wanted to ask, so as far as, is that what led you to implement it, to try to maybe, bring more identifications, like overall? So what led you to bring it to the hospital?
So the implementation of the NGS started from the perspective of the capabilities that we've been expanding. So as you are aware, our microbiology lab and American Health are expanding rapidly in the last few years. We have now more capability for testing. We are able to identify organisms with new different approach and have a whole different perspective from bench work, and also the susceptibility aspect is expanded. But one of the limitations that we have is the identification of certain organisms in our facility, because we depend heavily on the MALDI-TOF. That is the most advanced identification method that we have. Even when we try to validate MALDI-TOF for AFB and fungi, we always found limitations. So beside that, we use a lot of reference laboratory for microbacteria. For microbiology, they're probably familiar with the GenPro. The GenPro is this really old platform that was able to identify a very few mycobacteria group, like TB, MAC. So the equipment was discontinued last year. So we went through the process to get a different approach for mycobacteria. Was one, developing a multiplex PCR panel, a whole LDT in-house, or get the approach of NGS. So the NGS give us the opportunity to expand the capability of identification, being able to include bacteria and molds, but even to explore NGS in the near future for direct samples. So the idea was to be able to bring a solution in-house for mycobacteria that we can expand in the future, but it's also cost-effective. Just as a rough approximate, for NGS per sample, or maybe from this perspective, or NGS per isolate, from plate or from liquid media for a mycobacteria is cheaper than many of the multiplex PCR that are currently in the market. So for us, and when you compare that with some of the reference laboratories, especially for AFB identification, it's a significant cost saving due to this processing house. We have control over the process. We're able to expand and adapt to any change, but at the same time, we are able to expand our knowledge in that particular technique that we can expand to other solutions in the future. So in general, being able to reduce costs, increase our knowledge on this approach, and have a flexible platform for future application, not only for identification of isolates, but to be able to run directly from samples. So it's kind of like a mix of needs and ideas that we had from the beginning. And I think so far it's been working probably better than we considered. Um, um, and to be honest, the first step to getting to AGS can be, I would say scary, can be confusing because you don't know how to start. But when you own the process, like we did at Miguel, I mean, it's really not challenging, and especially if you are specifically focusing in infectious disease.
So definitely that's, I was going to ask about the process for identifying mycobacteria, and you touched about on the gene probe. And so I just had some questions about maybe if we can talk a little bit about the Oxford Nanopore technologies, and then, how does it work, and, how do you analyze the data?
Sure. So Oxford Nanopore Technologies is a company, I believe is based in the UK. It's they have a novel technology of DNA or RNA sequencing that provides data in a fast, accessible, and easy to use. And they're mostly involved in, I believe, research environment, but they have started to expand into other fields like environmental education and, of course, healthcare in a research use only format. And as far as how it works, so Nanopore has what they call the flow cells, and the flow cells have a bunch of tiny little holes which are called nanopores. These are attached to a sensor chip that transfers the data, and in the nanopores there's a current or a consistent electrical current flow that flows through it. So with this current that passes through it, whenever there's a DNA nucleotide passes through the little nanopore, it disrupts that electric flow. The nanopore, the device, is able to distinguish this characteristic disruption, or what they call squiggle. So this squiggle is then decoded into the different nucleotide bases, so the A, T, C, and G, or if you're doing DNA. So depending on what passes through the nanopore, it disrupts that current of flow, it produces the squiggle, and then that squiggle is then decoded into the different bases, and that's how, and then you get your sequence. And then as far as analyzing, the base calling is performed live in the instrument, or it could also be done offline using a different application. But then you have your base call data, and then you're able to put this into a application like a cloud-based platform like the WIMP or the What's in My Pot, or you can put it into the local analysis platform like the Kraken, and you put the what they call the FastQ data into that software, and then it would be able to give you, for our purposes, identification, or maybe if you're doing something else. But yeah, that's basically it.
We have challenges, and then we overcome those challenges. We bring the tests in, and then the question that comes right to for every technologist or people thinking and listening on the audience is, right, how do we validate this? About like ongoing QC and things like that pop to mind. So can you talk a little bit about the validation process of this?
Yes, definitely. So the validation process included a lot of different factors. Included things like evaluating different extraction protocols to what kind of quality DNA you need for your actual process. Included looking at all the different library kits that Nanopore provides. They have different flow cell types as well that have different amount of capabilities as far as data produced. Finding out how many different samples we're going to multiplex, and then of course how long are we going to sequence for. So we evaluate all these different factors. The actual validation was we did 120 microbacterial isolates. It included the rapid growers, it included Streptomyces as well, it included aerobic Actinomycetes, Nocardia. We also included tuberculosis in there, mycobacterial tuberculosis complex as well in there. So we had a total of 120 isolates. We compared the identification that we received from the Nanopore protocol compared to the reference laboratory identification that we had, and we just did an analysis that way. It was definitely successful. It was over 99% successful in the identification for those organisms that were included in the database. And as far as QC, we do have a process in which we have a positive external positive QC and a negative QC. For positive QC, we just chose an organism, a known organism, known QC, ATCC organism is Corynebacterium striatum, and we include that in all of our runs. We put it through the entire process to make sure that we're doing the extraction process right, the library preparation, and also the data analysis right. And then we also have a negative QC, which is just molecular grade water, which we also include in the entire process as well to look for any external factors or any kind of maybe contamination issues or anything that we might have. So we include that as well in our validation process.
So one of the interesting aspects that Daniel was mentioning is, so when we see typical validation process for NGS, we need to evaluate the efficiency of the structure, the quality of the DNA. So those are important factors. But the validation, the way that we describe the validation, using that, I'm also making sure that we have like this support, the pillar support for process was using the CAP, molecular pathology checklist, but also the microbiology checklist. So we needed to make sure that we are in agreement with this checklist and this process. So, but the validation was described for the process is, well, we have multiple modifications, we have multiple solutions that we've been implementing. Are we able to reproduce identification of those organisms using this different process and validating during the beginning to the end? We started trying to do extraction, and then we came with the idea to launch a physical disruption, and the amount of DNA was enough. Maybe it's not the most clean and high quality DNA for a whole epidemiological or whole genome sequencing epidemiological investigation, but is enough for identifying the organism. We explore different kits, we explore different reagents. The same thing with the database. So thing that we find out, we do a whole genome sequencing with one organism only. We are able to multiplex 6 organisms with one flow cell plot to do quality control, external control, using barcoding. So technically, with only 5 reads per isolate, we are able to identify the organism with a 99% accuracy. So that's one aspect. The other aspect is what is the percentage of all the reads for that particular barcode, and what is the percentage that is applicable for the organism that is the predominant one. We also were able to identify patterns of where the organism is not in the database. So the validation not only gives us the sensitivity and all the specification that we calculate statistically, but also give us idea to identify when something is not right or when something is not working as appropriate. Like the pattern of the identification of the code that the database gives you when the organism is not in the database is very characteristic, and this organism is not in the database. When you have a specific complex or group, you are able to recognize if you are able to identify that complex or group in a species level or not. So we need to move to another platform. So that was all part of the validation, and the adding the external quality control was also key. The Streptococcus, the Corynebacterium striatum, actually with a low concentration, still is able to be identified. So that's something that we're trying to do too, have the Streptococcus, the Corynebacterium striatum in a low concentration. So that way we know that we are able to pick and don't use the whole flow cell in some of the quality control. Negative quality control also being able to monitor any potential contamination during the process. So if this a very orthodox validation process? No, because this was adapted to our capability. It was adapted to workflow, on staffing, on space. So we have an area dedicated to this, but we're not doing amplification literally. So what we're actually doing is using whole genome. We need more DNA, we use more colonies. We need to clean DNA, we have a cleaning process. So we need better quality DNA for specific isolate like Microbiology System Group. We have another process that we actually integrate in the validation for better quality DNA, but it's a little more time consuming, costly, so we don't do that routinely. So the process was specifically adapted for the needs and the capability that we have. And I think that's, for us, it's being the best way to implement it.
Definitely touch on the things that I was going to ask, what worked well, and some of the challenges. And I also, so there was, now that you mentioned, well, before that, so you did it with, or the organisms were grown on solid media, and that's the type of the samples that you use, right? And then you mentioned, about Mycobacterium abscessus. So from what I understand, that was a challenge at first, but then not anymore. Or how did that work when you were doing the validation?
So actually, in our validation, we did include from solid media, but also directly from the midget broth tube. So we did validate both specimen types. Solid media included, the LJ slants, Middlebrook, chocolate agar. We validated from multiple different media types, but also we have a process that we validated, in which we use a concentrate from the midget broth tube to identify it. So that was also included in the validation. And then as far as the abscessus group, so for abscessus group, that was, I guess, one of the first challenges we encountered was when we're identifying Mycobacterium abscessus group, our current or our protocol, extraction protocol, the quality of DNA that we were getting really only allowed us to get to the complex part. So Mycobacterium abscessus group. But for that group, it's specifically important to get to the subspecies level. So either abscessus bolleti, or mescelensis. So for that one, we did have to validate a separate process for that, which gives us the really pure DNA. And then, but once we did that, we were able to subspeciate it, and it correlated very well. So now we're able to, once we get an abscessus group result, we're able to then go to that same sample, reprocess it using the other more stringent DNA purification process, and then we're able to subspeciate.
Okay, and there were also some challenges with the database, as I understand, right?
Yeah. So, of course, it's going to be the NGS identification is going to be dependent on the database that you use. So we validated two different databases, the WIMP and then also using the Kraken database. They use two different databases. But we did notice that during our validation that 3% of the organisms that we tested were not in either one of the database. So that's one of the challenges, or one of the issues that we had. But it was only 3% of it. So in that case, if we do encounter that, and we know the characteristics of when the result what it looks like when it's not in the database, we're pretty sure when it's not in the database based on the how it looks on the report. Then from there, we're able to if we can't bring it to a more if it's not part of a complex or something, we can report. If it's like if we're able to report out maybe a complex level like MAC or CMA complex or fortuitum, we're able to at that point then we will have to send it out to a reference site. But it was a very few amount of the samples, only about 3%.
So what about as far as next steps? Any other and I'm gonna Dr. Alexander touch on it a little bit. But what's next for this test?
So we have the capability for identifying isolates from media and liquid media for egg. We also have the same capability for solid media for bacteria. That was just recently, I think this week was the first one for bacteria from solid media. We are looking to expand the bacteria identification and mycobacteria identification from blood culture models, also blood culture models. So when we have an organism that we see in the bottle or rapid PCR doesn't identify any isolated specific organism, and they fail to grow in solid media, or we have challenge for identification, we're going to be able to go through this broth in the bottle, positive blood culture, and with a process that we are developing in-house, being able to do the sequencing directly from the bottle. So far, we're still in the process of trying. I believe we probably can do 5 for once. So I think we have enough capability in the flow cell to be able to do that. So that's the immediate application that we try to look for to expand with the bacteriology and AFB. We also are looking for candidates of specific yeast and molds. So we explored the option to be able to sequence Candida auris. So we were able to sequence few isolate for Candida auris and for a different approach, but also see the process with our NGS. We're going to use a very similar process to bacteriology for Candida or for yeast, but we're going to use a similar process for AFB for molds. Mold will be the next step for us. We know that many facilities that have a mycology lab, we're lucky enough they have an excellent mycology team, a lot of expertise in that area. But we know that many molds are challenged. They're still identified morphologically, using microscopy, and some of them only identified to genus level. So we are trying to see how can we integrate routinely NGS for molds and be able to expand the knowledge of these different species that we have across the world. Direct sample, that will be the next challenge for us, being able to implement a cost-effective, rapid whole genome sequencing from direct sample. And we're talking about high-quality sample. Some specific biopsy tissue, and probably BAL, and even NGS on CSF. So we're still exploring different type of samples with different matrix. We're going to try to see if how the capability that we have in-house is able to do that. One of the challenge is having probably a more robust comprehensive database. So that's something that we're also trying to explore, especially for direct sample. We know that it's a more challenge, but this is just the beginning. We're expanding not only our capability or solutions for organisms, but we're also looking for this year to expand the NGS capability with more instrumentation and even some of the agents.
Definitely. So definitely, very exciting times to be a microbiologist with all the things that go, and we see how much growth the field is doing. And if you find yourself in a place like like our lab or others like that, you get to experience that, and that's amazing. And for that, building on that, before I open the floor for any final thoughts, I wanted to ask Daniel, just like a lot of the audience listening in, just like myself, we're medical laboratory scientists, we work on the bench, we do all this work, and sometimes, all these terms, you hear them and then maybe think, oh, just you're thinking more of like a scientist in a lab, PhD level, and you got to work with all this. So how has this experience, what's the impact that it's had on you as a medical lab scientist and microbiologist?
Yeah, definitely. So it was definitely an interesting process. It was probably over like a 2-year process validation that we did. So it's funny, when Dr. Alexander first introduced the idea of gene sequencing, I think he posted it on a LinkedIn post or something. He was like saying, oh, Daniel's going to be in charge of implementing gene sequencing into our laboratory. And when I read that, I was like, oh my God, I don't know anything about DNA sequencing or genomics, anything like that. So I was like, oh man. So I started studying up on stuff and researching everything. And definitely the initial training that Nanopore provides, it was like the first introduction to it, which they introduce you to all the different terms as far as all the data, like FASTQ, FAST5, all these different, all the different terms. So it was a great introduction to it. And from there, that's when, because we started really the day after we started testing, and we started following the protocols. And from there, I just started really just doing a lot of research. Took a lot of different forums and YouTube and a lot of different avenues. But overall, at the end of it, I feel pretty comfortable in that subject, at least at a beginner stage. But for the regular microbiologists, they're not really. I guess you wouldn't be too aware of the different terms and because it is kind of like a whole different world you're looking into. So that could be, I guess, a little bit of a challenge, but not really a challenge. Just the first step. It's just a step of learning everything and catching up to all the different terms and that side of the field. But overall, it's super interesting once you really start looking into it. And for me personally, it's been great. I never knew back in school. I really did not enjoy this part of the class. But now that I've learned it, it's really probably one of my favorite things that I've done in my career. It's definitely very fulfilling and especially bringing it to the lab and validating it. And now I'm starting to train some of our staff. I'm starting to introduce the concept to everybody. Every time we have a run or something interesting, I will go into our technologists and I will tell them about it and give them a little review of what we found that week. So I'm already starting to kind of introduce it to them. But yeah, it's been definitely fulfilling, especially seeing once I start training and people start seeing or implemented it into the routine protocols. And it's definitely a very rewarding process. And I definitely enjoyed it a lot.
Indeed, right?
Well, I still remember the first round that we did. We knew the organism that were put in this sequencing, and when the result came back, I said, "Wow, all of them match." So it seems like the sequence is working. So that was a beginning. But I think that's an interesting question, Luis. What you mentioned is it's true. You don't have to be a PhD. You don't have to. Medical laboratory science, right? Many laboratory. Sadly, we are working sometimes with low staffing, high volume, and we just working on the bench 24/7 doesn't work, right? So even in some laboratory, it can become like a factory. You go in, you work, and you leave. So that's all that you do. But one of the things that we try to do at Avengel is to make sure that we just work at that point. I mean, that's important. That's all the patient that we have. We have to do it. But I think that was important for us to be able to everybody to be involved. In your case, you are our quality control. So you are responsible for the quality control in having a laboratory. So that's a large responsibility, something that I'm sure that you've been learning more and more and more and become natural. So this type of position is needed for microbiology laboratory. So being able to have the type of expertise and focus. The same thing happened with NGS. So a school for medical laboratory science teaching the basic of microbiology, and still many of those schools are teaching the old way. They don't have access to some of the technology that we have. And then we ask those technology coming, or those medical lab science coming to laboratory, clinical laboratory, to implement this technology they never saw before. So I think one point is, you don't need to be a PhD. You just need to have the willpower and the interest to learn and being able to do it. Of course, in the clinical setting, we also have to have all the regulatory process around, right? And that's part of also where my role comes into play. I want to make sure that everything that we do here is under the regulatory process. We are doing things that will improve patient care, so when it causes any harm to them. But we are the expert of microbiology. So we've been working on the laboratory for years. We know how the laboratory works. We know what we have a capability to apply a reasonable approach to different things. So I think this is key for every laboratory, and that would be great in the microbiology field, the clinical laboratories, the medical laboratory scientists. They don't just pull themselves back because they don't have a PhD. They don't pull themselves back because they don't have research experience. I'm a physician. I don't really have a lot of research experience, but I mean, the team that we have here in Advent Health, everybody just come together and we look for solution. And that's the plan. And always having a goal, patient care first. That could be only for improving the patient, the care of the patient, or could be actually to improving the financial of the department that can allow us to bring more solution for patient in the future. So as a medical laboratory science, we have the knowledge, we have the expertise, and I think we just need to take ownership of the laboratory. So I think that's the key.
Well said. Yes, definitely. We have the capability, and a lot of people, unfortunately, they're not aware of our profession and what we do, and that's something that we're working on. But definitely bringing that awareness of the impact of the work that we do, and how that benefits the patients. And yeah, we can just with projects like this, and we can do this type of work, and people need to know that. And it is great. And like anything in life, it takes work and it takes education. And just like Daniel did, doing the research and becoming prepared for this, it's something that we all can do. So those of you that are listening out there, it's very possible. You just have to do the work. And I said it before, and that's the secret to being a good microbiologist and a great one. It's just, repetition and education. So it's just, that's something that we need to know. And looking back, Daniel, right? I saw you the other day at work. You were doing like a blast, and I'm like, when a few years ago, when would you think or that you will be doing something like that? And me, I just finished a class, so seeing someone doing it, and I'm like, oh, you're doing blast, and we talked a little bit about that. So it's definitely amazing, how far we can grow in this job and our knowledge and our education. So it's just amazing. Is there anything else that either of you want to add?
No, not really. Just thank you for having me. This was my first podcast, so this is definitely a fun experience. Yeah, NGS has definitely been super fun to work with. We started with AFB organisms. Now we've moved on to bacteria. So we're already starting to see organisms that we weren't able to identify before. We're starting to see how there may be some emergent pathogens or something that we weren't able to recognize before. So we've already started to see that. And, just with that, we've already started. We have so many ideas for NGS. We have so many different avenues that we could go in. It's going to be very exciting. And this is really just the beginning of our NGS project, as we're looking to do so many things with this, and it really opens up our possibilities. So, but thank you so much, Luis.
Yeah. So thank you, Luis. I think this is a great opportunity to show our results or work. As Daniel mentioned, this has been an amazing project. The other thing with NGS for us is NGS doesn't live in a bubble. Anything that coming out from the NGS result is we don't take it as a face value. So it's important for us to do clinical microbiological correlation. If the organism morphologically doesn't match with the NGSA, we have to go, you have to Google how are the morphology, where is the biochemical, trying to match. If we don't have that correlation, we question the NGS. So the microbiological experience and information that we are always have experience for years also from what is coming from the NGS. So I think that is important. That's what makes us also make the implementation of NGS in a clinical micro lab when we also perform routine microbiology, so you have that connection. So the NGS, because the NGS says that, doesn't mean that it's true. We always question it. And I think that's the key. Question what we see, but also the NGS can open the way for us to see the routine microbiology in a different way. Just like Daniel mentioned, we have a new isolate that we never saw before. It's a catalyst positive streptococcus. So it's been described, but as the way the microbiology has been thinking on the bench, NGS probably will put some challenge for us to change. And I think that's welcome, right? So that can open the opportunity for us to move a little beyond what we know and expand that capability. And this is in multiple areas. So we really appreciate the opportunity that you give us to be able to share with everyone our experience.
Definitely a pleasure having you on Let's Talk Micro. Thank you for taking the time, and what a great message to close with. And that's something that, I talk a lot about in the podcast, and with instrumentation and testing, I talked about how sometimes, we become too reliant on things like MALDI-TOF, but the correlation of the organism, just because you're getting that ID doesn't mean, hey, MALDI ID it. So it's all good, right? You have to make sure that the whole thing matches, that it fits the profile. And that's a challenge that we have as people might become a little complacent with technology. And that's something that we need to keep in the back of their mind. It's just, we have to make sure, right? We're putting that idea out there. We're impacting the life of a patient. That's what we do it for. So we have to be very careful with things like this. So once again, thank you so much for taking the time to being on Let's Talk Micro. Well, there you have it. Thank you, Dr. Alexander and Daniel Navas, for some great information about next generation sequencing. And as you know, the Let's Talk Micro podcast is available on all podcast platforms, so please go ahead and subscribe to the podcast, download episodes, and if the app allows you to do so, please go ahead and leave a review. Thank you so much for the support. You can find Let's Talk Micro on social media, on Instagram, TikTok, YouTube, and Blue Sky Social as Let's Talk Micro, on X as Let's Talk Micro 1, and on LinkedIn as Luis Plaza. If you have any feedback, any suggestions, you can do so via social media or via email at letstalkmicro@outlook.com. And if you want to support the podcast in any way, you can do so via a Venmo link and via Buy Me a Coffee, KOFI, both links available on the show notes. And if you are looking to learn more about antibiotics, please check out www.learnantibiotics.com and the Learn Antibiotics book available on Amazon. These resources include cheat sheets, practice tests, games, and more, and they are being used by thousands of people worldwide and may be helpful for you or your colleagues. And these are some great resources from Dr. Timothy Gauthier, a very passionate pharmacist. And that, my dear audience, is the end of this episode. I hope you enjoy learning about next generation sequencing. As always, I enjoy sharing this information with you. Please stay tuned. Great content your way. There's going to be some more episodes about next generation sequencing. So stay tuned. Thank you so much for the support. And please continue bringing that passion to what you do. It is so important. You do such great work. So, as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time. Bye.